Hello everyone. Non-homogeneous equation of first degree. The variables we are considering x and y. Okay. Non-homogeneous equation of first degree in x and y. So if the given equation is non-homogeneous equation, then we need to reduce that non-homogeneous to homogeneous differential equation. In our previous videos, we have studied how to solve homogeneous differential equation or how to find the general solution to the given homogeneous differential equation. So, by using that method, we can solve non-homogeneous equation also. Please go through that video for find the solution to given homogeneous differential equation. So, it is considered non-homogeneous equation. Okay. Consider the equation which is in the form dy by dx equal to a1x plus b1y plus c1 divided by a2x plus b2y plus c2. Call this as equation 1. Here c1 and c2 are constants. Again, this a1, b1, a2, b2 are also constant itself. Are also constants. We have to make this equation as homogeneous equation by using a following method. First, we need to put x equal to x1 plus h and y equal to y1 plus k. Substituting x and y in the given non-homogeneous equation, equation 1, we get dy1, in the place of y, we have y1 plus k. Derivative of y1 plus k is y1 itself, because k is a constant, derivative of constant is 0. So we left with y1 itself, and derivative of x, in the place of x we have x1 plus h. So derivative of x will be derivative of x1 plus h. Since h is constant, we left with only x1. So dy by dx1 will be the term. This is equal to, here a1, in the place of x we have x1 plus h plus b1 into, in the place of y we have y1 plus k plus c1 is there, whole divided by a2. Again the value of x, x1 plus h plus b2, in the place of y we have y1 plus k plus c2 is there, provided this h and k are constants. Now we need to collect the variables and the constants as its group. So this will be equal to a1 x1 plus b1 y1 plus, here a1 is constant, h is constant, right? So a1 h plus b1 k plus c1. This will be the term of constants, and divided by a2 x1 plus b2 y1 plus, here a2 h plus b2 k plus c2. Right, call this as equation 2. The value is dy1 divided by dx1. Okay, now to make this equation 2 homogeneous, we need this term and this term as 0, right? Because homogeneous differential equation will be in the form dy by dx equal to some function of x comma y divided by some other function of x comma y. Here constants will not be there, right? So we need to do that this constant value 0 and this constant value 0. So I will consider the constant value A1H plus B1K plus C1 equal to 0 and A2H plus B2K plus C2 equal to 0. Okay, now we need to find out the value of H and K so that this equation and this equation becomes 0. Okay, so let us find out this. I will go by the method. Here we need H, K and 1, right? So A1, A2, B1, B2, C1, C2. Again A1, A2, B1, B2. No need of C1, C2. So for starting from this and this, we need to multiply B1 and C2 minus B2 C1. Again this C1 into A2 minus C2 into A1. Again A1 into B2 minus A2 into B1. Right. So H divided by B1 C2 minus C2 B1 C2 minus B2 C1. B2 C1 equal to K divided by C1 A2 minus C2 A1 minus C2 A1, and this is equal to, here 1 is there, 1 divided by A1 B2 minus B1 A2, right? So we have the equation like this. Call this as equation star. Okay, now substituting here, whenever you consider this first factor and third factor, you will get the value H. Whenever you consider second factor and the third factor, you will get the value K, right? So like this we find the value of H and K here in this method, in this step itself. Now we need to substitute the value of H and K in equation 2. In equation 2 we have already derived. So we get dy1 divided by dx1 equal to a1x1 plus b1y1, because here this term will get the value 0, right? So divided by a2x1 plus b2y1 itself. Again this value will get the value 0. So we left with only this much. Call this as equation 3. See here, this is homogeneous, right? We have no other separate constants. So equation 3 is homogeneous. Equation 3 is homogeneous in terms of x and y. Hence, at last we need to substitute the value of y1 and x1, right? So y1 equal to x1 into v and differentiate. We get dy1 divided by dx1 equal to v plus x1 into dv by dx1, right? Substituting the value of y1, and dy by dx in equation 3, dy1 by dx1, right? In equation 3 we get the general solution. Okay, we get the general solution. Again we need to substitute the value of y1 and x1, because we get the value in terms of x1 and y1 in this case. So again we need to substitute the value of y1 and x1, because the value of x is x1 plus h, y equal to y1 plus k, implies x1 equal to x minus h, y1 equal to y minus k. Here the value of h and k is obtained in equation star. So we need to substitute the last value, so that we'll get the required general solution. Okay, let us solve one problem so that we'll clear the method. Okay, let us go for that.